That way.
Les, here's the setup as I started this morning. The 7-amp motorcycle battery running the circuit. This is the feedback control. The stator motor oscillating without the rotor. Charging the 18-amp battery and the other 7-amp. The meter right now is hooked up to the run battery. You can see it's at 12.1728998. Not moving very much. So the run battery is going down real slow. Okay, I'm going to hook up to the 24 volt side. Okay, hooked up. And here's our 24 volt side charging. So you can see definitely charging 2 with 1, but it's probably just a surface charge. So anyhow, that's where I'm at this morning. I hate to be breaking in here and pausing the video and doing voiceovers, but I sort of have to because I have about 4 or 5 minutes of video here that didn't have any sound on it. I was doing the video as I was going along and kind of ran into something very interesting, and it it actually surprised me so much that I didn't have anything to say, so I kept quiet and just went about poking around and trying to figure out what was going on as I went. I think you'll like this. Okay, so check this out. The tester triggers at 90 volts plus. It's supposed to be safe from 90 to 1000 volts. I'm touching the top of the battery and the thing goes off. So I immediately grabbed my camera and thought I'd better document what's going on. So you're basically seeing this as I saw it myself. So what's going on here? I only have had this pen for 2 days, and I don't know much about them, but it's really nice to find the hot wire in your house wiring. It works fine. But look at this. It goes off on everything. Now the setup here is running on 12 volts to begin with, and the output is connected to the battery, so there just shouldn't be any high voltage like this running around anywhere. Yet, check this out. Maybe someone here watching the video has seen this before or has a clue of what might be going on. I have a few ideas that I can talk about, but for now, check it out. This is pretty interesting. See, it didn't go off on the plastic on the top of this case, but as you get close to where the coil is on the meter inside, it goes off. And it's going off on wires that aren't connected. It's pretty surprising to me. Now, you'll see here in the video that I stopped this, put it aside, and thought I'd come back to it. This effect came about when I hooked the ground clip from the scope up to the ground of the circuit. And I just thought, well, that's going to happen again if I connect up the same way. So I went on to working on a pulsar circuit and decided to come back to this later. It hasn't worked since then. Okay, this is about a week after the last clip you saw, and I put that experiment aside for a little bit, thinking that I could come back to it any time and hook up the scope probe and get the pendulite and so on. But anyhow, so I went on with this other oscillator circuit, and I'll explain what I have here, and then try to connect it back up with how I started and the high voltage and pen and stuff like that. Anyhow, what I have is a modification to this stator motor. I used to have these 10 coils in series, but what I did was I split it now, so I have 4 on this side, 4 on that side, and then the trigger that you've seen in the other videos. So what I have then is the SSG trigger running the motor with 4 coils, and then 4 coils going over to the circuit, and a bridge rectifier which charges a capacitor, and then a pulsing cap dump circuit. So we charge the cap up, dump it into the battery. Anyhow, I have here a variable capacitor that I use for the timing of the pulse circuit. And over here, as you've seen in one of the earlier clips, I have this resistance substitute box hooked up here to the base of the SSG transistor over to the positive rail. And by adjusting that, I can get the circuit to oscillate on purpose. And so it's good to start off with about 10K if you're going to ever monkey with that. So with that being said, I'll start this up. I have the 7 amp battery over here, the motorcycle battery, and I have a 18 amp battery on the run side. Amp meter is hooked up from the in series with the 18 amp battery, so we can see how much current it's taken to run the circuit. And let me plug that in and we'll get going here. Okay, you see immediately it's drawing 142 milliamps. And over here you can see that the battery voltage is going up on the 7 amp battery. So it's self-oscillating right now. I'm going to make that easier to see. I'm going to unplug that again and put one of these rotors on the motor. I can do it with one hand. There. I'm going to switch off the oscillator and start this off again. So now this will run with in a standard mode. You know what? I'm going to put on a bigger rotor. Hold on a minute. Okay, so I've put on this big rotor here. It has pretty heavy magnets on it, so we get a lot of effect here. I can show you something. I'm going to disconnect the collector of the SSG transistor going to the capacitor, and you can see just by turning this a little bit, you can see the neon bulb flashing here, so you can see that this thing is really capable of generating some high voltage in the standard SSG sense of the word. So I'm going to hook the capacitor back up here. Okay, hooked up, and I'll start this running. This is I'm using this because it kind of emphasizes the effect a lot. It's running a little bit slow because of the heavy magnets, but you can see that we're pulsing now, and the battery charge is going up. Over here on the scope, you can see the capacitor charging. I have the baseline set at the very bottom line of the scope. I'll show you. I'll put it to ground. So what you're seeing on the 5 volt range is the bottom of the trace is at the charge voltage on the charging battery. You see the capacitor going from that 12 volts up to about 22, 25 volts and dumping into the battery. So that's doing what it's supposed to do. You can see this diode flashing that's hooked up to the timer circuit. All pretty normal. Okay, I have a scope shot here that might help explain things a little better. The trace on the bottom is the square wave from the timer circuit, and the trace on the top is directly from the capacitor. Okay, so if I'm saying it right, the square wave, when it's low, the capacitor charges. Then when it goes high, or into the duty cycle, you can see that the FET turns on, or the SCR, and the cap is dumped. The circuit is sort of different from what you see normally. This circuit here started off to be one of John Bedini's popular ones, where the pulse circuit is sort of isolated from the input circuit of the SSG. I had not real good luck with that, so I have this thing all bastardized. I have the circuits tied to ground. Right now my SSG develops, it seems, way too much high voltage to be consumed by the secondary coil of the SSG and the capacitor. So with this in mind, I'm dumping the excess high voltage from the SSG back into the capacitor and using the cap dump both. So that's giving me some results, but let's get on to something else. I'm going to stop the well, no, I'm not. I'm going to put the oscillator on now, and you can hear the motor speed changing with the pulse. Now if I stop it, we'll still charge. I think you can hear that. Take the microphone out of here. Okay. So if you watch that, or listen to that, and watch the scope, you can see that the oscillation changes with the charge and discharge of the capacitor. And I like this pretty nice. I mean, take a look at this. I'm running now at 89 milliamps rather than 200 or 300 milliamps. And am I charging? Yeah. It goes up and down, the charge. It'll drop then go up, but every time it goes up, it goes a little higher. I can increase this action here a little bit by adjusting the SSG off. Went too far. So now it's drawing 112 milliamps. And the charge rate goes up a little bit. You can also change the feedback on this resistor. That also increases the charge rate. Watch, it's going down, but it'll go back up here, as you can see. Now, when you change that, we're charging the capacitor higher. Now we might be charging up to 40 volts and then dumping it. That's probably damaging the battery, but I think it's damaged to begin with. So anyhow, that's what's going on with this circuit. And oh, of course, I can change the pulse frequency by changing the capacitor. Of course, when I do that, the charge of the capacitor goes way up. But I could put a bigger capacitor in. I'm not so sure how much I want to shock the plates in that battery. So anyhow, that's what's going on. Don't ask me too much about the circuit, because I'm not confident at all that I'm doing anything here that's worthwhile. This is kind of interesting with the feedback, though. I thought you'd like to see that. And I was doing something similar when I got this pen to light up. So this is what the whole this is what the video is about, anyhow. And now I've got nothing. I just literally have nothing with this pen like the other clip. And I thought the minute that I hook up a ground from the scope that it would start doing that again. Hold on, I gotta get this mic back. Alright, mic is back in place. What I'm going to do is take this off here to quiet it down a little bit. It's still working just the same, you can see. I better cut back the charge on that capacitor a little bit. And like I said, I was doing something like this in the other video, and when I hooked up the ground, I had all this effect going with this pen. And now I don't have anything. There's nothing anywhere. Yet the pen works. You can see I'm on the wire here to my soldering iron. That side doesn't. This side does work. So it's picking the hot. Don't know what to say about that. I'm coming to a conclusion, though, that the other circuit may have been self-oscillating and sort of looking like some of the experiments you see on Lid Motors channel or Laser Saber, where they have one wire lighting a diode, or you can move a diode around the coils, and there's some high voltage RF transmission or something. So that's what I'm thinking, and I think that's why maybe I can put the other circuit back together and give it a try again. Okay, here's something that goes in the for whatever it's worth category. This is the starter motor running with the SSG. I have the charging battery, or the battery being charged, is two motorcycle batteries in series. They're 12 volts, 7 amps. And I have the negative side of the battery hooked up to the negative rail on the SSG. So the motor here is drawing 300 milliamps on the input, and that's a lot more than I usually use for anything. But here's what I wanted to show you. I have a 1 ohm precision resistor in the charging side, and I have that on the scope, so you can see what's going on here. Let me turn some lights off. That isn't very good either, is it? The lights back on. Okay, so I have the scope set at 0.1 volt per division, and I have the baseline set right at the bottom line of the graticule, so you can see that I'm measuring current here. So I have 300 milliamps going in, and at 0.1 volt per division over the 1 ohm resistor, I would estimate I'm 1, 2, 3, 4, 5, 6, 700 milliamps per pulse here being charged into the battery. So probably charging more with current than in high voltage here, I'm guessing. So let me stop the rotor here. Alright, so now just plain oscillating. Pretty neat, huh? So that's what she looks like. That's what's going in. Current-wise. Voltage, or my current here on the input jumped up to almost 400 milliamps. And so I don't know whether that's usable or not. I still can't get any of this high voltage readings on anything. I've tried and tried, and there's nothing going on anywhere here anymore. So I should have messed around with it while I had it. I can't get anything back on that. Anyway, I don't know whether that's interesting or not. I just thought I'd document it since I saw it. We'll go on. Not hooked up. Man, what the heck is triggering this thing? Well, okay, anyhow, I hope everybody made it this far into the video. Les, thank you for sharing your ideas on the pulsar circuit. I appreciate that. Okay, Rem, pack it up. We're out of here, buddy. By the way, I told you to roar like the MGM lion at the beginning. You sounded more like a constipated chicken or something. I think you're going to have to work on that a little bit, buddy.